In section 3.3, we talk about graphing linear functions. And so by the vertical line test, we know that all linear equations except those whose graphs are vertical lines are functions. So for example, we know that y equals 2x is a linear equation in two variables, and below you will see its graph. And so they just picked some random x values and plugged it in to find the corresponding y values. Now because this graph passes the vertical line test, we know that y equals 2x is a function. And just as a reminder, the vertical line test says that if I can draw a vertical line anywhere on the graph and only hit one point, then it's a function. So let's graph g of x equals 2x plus 1 and compare this graph with the graph of f of x equals 2x. So I'm going to start with the f of x equals 2x, which is the graph that we have above, and I'm just going to copy and paste it. So we had the point 1, 2, we had the point 0, 0, and we had negative 1, negative 2. Let's go ahead and graph g of x, which is 2x plus 1. So I'm going to pick some points for x and plug it in and get the corresponding y values. So let's go ahead and pick the same ones that they did above, negative 1, 0, and 1. And we're going to plug this into our function g of x equals 2x plus 1. And so we have g of negative 1 is 2 times negative 1 plus 1. Well, 2 times negative 1 is negative 2, and negative 2 plus 1 is negative 1. And so that means we get the point negative 1, negative 1. Let's plug in 0. So g of 0, that's 2 times 0 plus 1. Well, anything times 0 is 0. Plus 1 gives me 1. And so we end up getting the point 0, 1. And we're going to plug in g of 1. We've got 2 times 1 plus 1. Well, 2 times 1 is 2, plus 1 is 3. And so we get the point 1, 3. So let's go ahead and plot those points. We've got negative 1, negative 1. We have 0, 1. And we had 1, 3. So do we notice anything about the pink and the orange points, respectively? Well, if we notice, the orange dots are just 1 unit below the pink dots. And so what ended up happening is that our g function shifted up 1 unit from that original f function. And so we've got g of x down here, which is 2x plus 1. And so in general, a linear function is just a function that can be written in the form f of x equals mx plus b. So for example, g of x equals 2x plus 1 is in this form, where m is 2 and b is 1. So in general, if a linear function is written in the form f of x equals mx plus b or y equals mx plus b, the y-intercept is 0, b. And so that means that whatever is being plus or minus at the end here is going to become my y-intercept, which is where it crosses the y-axis at. So let's go ahead and find the y-intercept of the graph of each equation. We have f of x equals 1/2 x plus 3 over 7. And so my y-intercept is going to be the 3 over 7. And so let's go ahead and write this in an ordered pair. The y-intercept always has an x-coordinate of 0. And then we have our 3/7. Let's go ahead and do the second one. We've got y equals negative 2.5x minus 3.2. And so negative 3.2 is going to be my y-intercept, and we have the point 0, negative 3.2. And so intercepts are usually easy to find and plot since one coordinate is already 0. So for example number 3, we're going to find the intercepts, the x and the y, and then graph 4x minus 5y equals negative 20. So the x-intercept is when y is equal to 0. So let's go ahead and plug that into our equation. We have 4x minus 5y equals negative 20. Well, we're plugging in y equals 0. So 4x minus 5 times 0 equals negative 20. Well, anything times 0 is going to cancel, and we end up with 4x equals negative 20. And to get x by itself, we want to divide by 4. And so it cancels on the left-hand side, and we get that x equals negative 5. And so that means we have the point negative 5, 0, because we let y be 0 in the first place. So let's go ahead and plot that. We've got negative 5, 0, and we need to find the y-intercept. The y-intercept, we let x be 0. So we have 4x minus 5y equals negative 20. Plugging in x equals 0, we've got 4 times 0 minus 5y equals negative 20. Well, anything times 0 is going to cancel, and we end up with negative 5y equals negative 20. We want to get y by itself, so we're going to divide by negative 5. And so it ends up canceling on the left-hand side, and we get that y is equal to 4. And so we end up getting the point. We let x be 0, and we got y equals 4. So we're going to plot that at 0, 4. And then all we have to do is connect these 2 points to make our line. What about graphing vertical and horizontal lines? So the equations x equals c and y equals c, where c is a real number constant, are both linear equations in 2 variables. So although there's only one variable present, it's still written in 2 variables because we could write this as x plus 0y equals c, or 0x plus y equals c. So there are 2 variables, it's just kind of hidden. So we want to graph x equals 2 and y equals negative 3. Let's look at x equals 2 first. So I'm only giving you stipulations on what x has to be equal to. It doesn't tell me anything about y. And so you can give me any y value as long as x is equal to 2. So we could do 2, -1. We could do 2, 0. You could do 2, 1. Any of those satisfy the fact that the x coordinate is 2. And so let's go ahead and plot those. We have 2, -1. We have 2, 0, and 2, 1. And then we just want to connect. And so you can see that we end up getting a vertical line. And so anything of the form x equals c is going to be a vertical line. What about y equals -3? So now I'm not giving you the stipulation on x, I'm giving you the stipulation on y. So as long as y is -3, x can be whatever you want it to be. So we could pick a -1 as long as y is -3. We could pick 0 with our -3, and we could pick 1 and -3. I'm just picking random x values. You could pick whatever you want. And so let's go ahead and plot those. We've got -1, -3. We have 0, -3, and 1, -3. And so when I end up connecting those dots, I end up with a horizontal line. And so that means anything of the form y equals c is going to be a horizontal line.